we're going to be looking at 2.4, solving equations with variables on both sides. So after today, you should be able to use all of our general steps for solving equations. So if we look at those general steps, we always use the distributive property first, then we combine like terms. Our new step is to move variables to one side, then we undo addition and subtraction, and then we undo multiplication and division. So let's look at some examples. If we look at example 1, part A, there's no distributive property to be done because we don't have any parentheses. We can't combine like terms because 5x plus 13, they're not alike. 2x plus 22, they're not alike. But what I do see is that I have variables on both sides. I have a 5x and I have a 2x. It really doesn't matter which variable you use, but I like to pick the smaller one because it's less likely that I'll have to deal with negatives. Now, when you move the entire variable over to one side, you use addition or subtraction to do this. Since I started with a positive 2x, I'm going to use a minus 2x to move it to the other side. So 5x minus 2x is 3x. So I have 3x plus 13. 2x minus 2x is 0. It cancels out. So I'm left with 22. Now this is a two-step equation. Now I'm going to undo addition and subtraction. So I'm subtracting 13 from both sides. So I'm left with 3x equals 9. And then my last step, it's 3 times x. So I divide both sides by 3. So my answer is x equals 3. So if I look at example B, this one I do have to use a distributive property because there's parentheses. So I'm going to distribute the 4. So I have 8y, because 4 times 2 is 8, plus 4. On the other side, I have to distribute the 2. So I have 2 times y, so that's 2y. And 2 times negative 13 is negative 26, so I have minus 26. Now the next step would be to combine like terms, but I don't have any like terms on the left side or the right side of the equation. So my next step is to move my variables to one side. Since the 2y is smaller, I'm going to move that over. Since it was a positive 2y, I move it over by subtracting 2y. So 8y minus 2y is 6y. So I have 6y plus 4. The 2 and the negative 2 cancel, so this equals negative 26. So from here I'm going to subtract 4, because I'm undoing addition and subtraction. So I get 6y equals negative 30. And then my last step is to divide by 6. So negative 30 divided by 6 is negative 5. So I have y equals negative 5. So for C, again, I have parentheses. Now this negative, remember, if you don't see a number, it's like a negative 1. So I'm going to distribute the negative 1 to both of my terms. So on the left side of the equal sign, it stays as 2x plus 7. On the right side, this becomes negative 3 plus 2x, because negative 1 times negative 2x makes a positive. From here, I'm going to go ahead and I'm going to move my variables to one side because I don't have to combine any like terms. Well, when I do this, I have minus 2x, minus 2x. Something happens. 2x minus 2x is 0. We could say 0x, but it means the same thing because any number times 0 is 0. So we usually don't write that in, so I'm going to erase that. So what I'm left with is 7 on this side. Over here, the negative 3 I haven't done anything with. Well, 2x and negative 2x, that also cancels to 0. So what happened? My variable's gone. If your variable disappears during your equation, they cancel each other out, and you're left with two numbers. If the numbers are not the same on either side of your equal sign, we say this has no solution. So problem C has no solution. So let's look at that a little more closely. Before we look at example 2, there is some new vocabulary, so we call this an identity. And what an identity equation is basically they're equations that are true no matter what value is plugged in for the variable. So in an identity, you could plug in 10 and the answer would be true, or the statement would be true. You could plug in 5,000 and the statement would be true. So let's look at example 2. We have, for A, negative 6A plus 3 equals negative 3 times 2A minus 1. So for this side, the left side, we don't have to distribute, but for the right side, we do. So I have negative 6A plus 3 on this side. Negative 3 times 2A is negative 6A. And negative 3 times negative 1 is positive 3. I don't have to combine any like terms, but I need to move my variables to one side. I'm going to use the negative 6A over here. And since I'm always adding and subtracting when I move the variables, and I'm moving it to the other side of the equation, I wanted to use opposites. So that's why I added 6A. Well, negative 6A plus 6A, that cancels to 0. So I'm left with 3 on each side. Negative 6A plus 6A, that cancels to 0. So I'm left with 3 on this side. Well, this looks similar to the last problem, except the numbers are the same on each side of the equal sign. If that's the case, we call this an identity. So meaning I could plug in any value for x, and both sides of the equations would be equivalent. So this is an identity. So let's look at B. Here I'm going to distribute the 2 because I've got parentheses. So 2 times 2k is 4k. 2 times negative 1 is negative 2. On the other side, I'm distributing the 4. So 4 times k is 4k. 4 times negative 2 is negative 8. I don't have to combine any like terms, but I need to move my variable. It's a positive 4k over here, so I'm going to subtract 4k. When I do that, 4k minus 4k is 0. That cancels. Over here, 4k minus 4k is 0. It cancels. So I'm left with negative 2 equals negative 8. Since negative 2 does not equal negative 8, this one has no solution. So let's try one last problem. So the 5y plus 2 on the left side, this one, I don't have to worry about distributing because there's no parentheses. On the other side, I'm distributing a fraction. That's okay. Same process. 1/2 times 10 would be 5, so I have 5y. 1/2 times 4 would be 2, so I have plus 2. There's no combining like terms, so I'm just going to move my variables to one side. I'm subtracting 5y from both sides. Well, 5y minus 5y cancels to 0. I'm left with 2. Over here, 5y minus 5y cancels to 0. I'm left with 2. Since my variables canceled out, and it's the same number on each side of my equal sign, again, that means it's an identity. So this was solving equations with variables on both sides. Remember, every time you're solving an equation, it's important that you follow the steps exactly in the correct order. So we use a distributive property, we combine like terms, we move our variables to one side, we undo addition and subtraction, and then we undo multiplication and division.